So this is the second lecture in the digital clock project series, and in this I'm gonna discuss about how to configure the RISC workspace to build for a RISC-V target, or in other words, how to cross-compile or how to configure RISC to cross-compile for a different target than the host target. So in the previous lecture, I discussed about setting up the RISC workspace, and we thought if you just build and run, so you can see that it displays the hello world. That's because in the binary crate, when we created the binary crate with cargo new command, by default this would have the main.rs file with a print line to print the hello world. But this executable is built for the host on my x86 Mac Mini. So it's better to briefly know the difference between compiling and running on a target, which is same as the host, and cross-compile, in which case the machine on which the source is built is different than the target on which it is run. For example, on the host compilation, we have the source code, and in my case it's built for x86, and the tool chain used is the tool chain for this is same as the target is same as the host machine, and once that's built, the executable is run on the host, which is my Mac Mini, and it's an x86 based Intel Core processor. And this is the main thing, which is like built and executed in the same machine or target, which is Mac Mini. However, what we want is to build the code on my Mac Mini, but it has to be built for a RISC-V target, not for x86, and it has to be run on Hi-Fi 1 Revision V board. So in cross-compile or in cross-compilation, the code is built on a different target, and then the executable is moved to the target and executed from the target. In this case, it is a Hi-Fi 1 Revision V board. Okay, so it's also handy to know a few things about RISC-V. So RISC-V is a tool which helps you to manage the RISC tool chain. Okay, so for example, if I issue this RISC-V target list, you can see the list of targets that the RISC compiler in my host machine supports. So these are all the targets, and you can also see, though this tool chain has the support for all these targets, only three of the support are implemented. One is RISC-V 32MAC unknown non-ELF. This is for my this is the same as the processor which is there in the Hi-Fi 1 Revision V board, and I have also installed support for an ARM v7, and this is my host toolchain for the host computer, which is an Apple and x86 base. So these are all the tool chains that is installed on my host, though it supports a lot of other targets. Okay, now what does this naming convention, if you're not familiar? So this naming convention is sometimes called as target triplet. So the first one represents the target, and the second one is the vendor, and the third one is environment or operating system. Sometimes you call this a triplet, but there are you can call this as a quadruple, but effectively it was called as triplet in LLVM compiler. So processor, vendor or architecture, vendor, environment, and the binary format. So for this target, when the toolchain has set for this target, it will build the code for a 32MAC processor, and vendor is unknown, and this can be sometimes Linux or Windows. However, here it is none, and the binary format is ELF. executable loadable. Okay, so now let's go back and set the target in our Rust workspace. So far we have just created this cargo.tyml file and added the workspace section here. So this cargo.tyml file is the file which Cargo uses to track the dependencies. Okay, so this configuration file is for the Cargo. However, Rust provide an alternative option to add a configuration file which can be passed to the toolchain or compiler. Okay, so make sure that you don't mix up this cargo.tyml file at the root of the project and /cargo. Okay, so if you create a .cargo directory and create a config file, you can also, this config file should also be in the TOML format, and here you can add custom settings which can be passed to the toolchain or compiler. Okay, so let's set that target here. So build section, so when cargo build is run, which target should be set for. So let's paste here. Okay, so now I have set the target as RISC-V 32 MAC unknown non-ELF. Now let's try to build. Now you see, before it passed, but now since we have this one line by which we set this target for RISC-V, now you see a lot of errors. So let's go through each one and resolve that. First one, it says this target may not support the standard library. So as you know that in Rust, by default, the standard library is included. It's not like C where you include explicitly with the hash include std.h, but here by default it would be included. And since this target, this compiler says that this target does not have a support for standard library, let's exclude that from this. So how do you do that is std. So this is an inner attribute whenever you have a hash and exclamation mark. This would affect the entire crate. So we are adding it inside the source/main.rs inside the binary crate. That means the entire binary crate would be built without the standard library. And we would also not include the main, because this main and the standard library goes hand in hand. So if the target supports the standard library, so that what the Rust would do is it would do the needful, do the memory management, set everything, and then it would just jump into the main function and execute that. However, since this does not have the standard library, we can't have the main as well, and instead you can call this as an entry point for now. Okay, now let's build, and since we have configured this on the binary crate, we should also do it on the library crate, which is the drivers here. So these files, so these code are added by default by the whenever we create a new cargo library or the cargo new command, then it would create, if you create a binary crate, the main.rs would be created by default by the cargo new command, and for a library crate it would add these two basic code. You can just remove this, it shouldn't be a problem at all. You can just, for now it's not used at all, you can just leave it, or you can just remove this. That should not make any difference. Okay, so now let's build again. So now since we excluded the standard library, this print line is part of the standard library. Since we do not have support for that, let's remove that and add a simple loop to get through this compilation error. Okay, so now it says that a panic handler is required. So Rust, it's mandatory in Rust to have a panic handler so that Rust knows. So Rust would call that whenever the system panics. And if the target supports the, if there's a standard library support for the target, then panic handler, there's a default panic handler inside the standard library. However, since our target doesn't have the standard library support, so we have to we have to create or write our own panic handler. And how do you do that? All we need to do is follow the error, whatever it throws. So if you scroll up, it says this function is required. And if you, since we excluded the standard library, by default the minimal library that would be included in the Rust is the core. And if you scroll here, you can see here this, whenever you use this core library, we should provide this panic handler, and this function takes one argument which is of type this. Okay, and you should also mark your implementation using panic handler. So we have already marked that implementation. Now let's write a function panic1, and that should take an input. Now let's fill in. Let's call the parameter, and again let this function just keep looping. Okay, first I'm trying to resolve all the errors. So what it says now, it says use of undeclared create or module panic. So we can just include use core. And the last one says the panic handler function should not return. So in Rust, when you have the return type as exclamation, that means that function should not return. So loop, of course, it won't return, and can save and build. Great, that's it. So now if you see the ls target RISC-V debug, and you can see there are, one is the library create, that is the libdrivers.rlib, that's the output of the library create, and digital_clock is the output of the binary crate, or the built artifacts of the binary crate. If you want, paste, and how to confirm if this has been built for RISC-V, we can just -yes. So the readelf is able to read. Let's read the headers. Yeah. So see, it says that clearly that the LF has been built for RISC-V. Okay, so that's it. That's how we set the environment or the configure the Rust workspace to build for a RISC-V target.